high dynamic range of 2,500,000 to 1 revolutionizes spectral measurement. The OPAL-Luxe is a multi-channel spectrometer with an unprecedented ultra-high dynamic range over a wide wavelength range. Simultaneous multi-wavelength spectral measurements are possible and are particularly effective when strong and weak signals are present simultaneously. A spectrometer is an optical instrument that measures the spectrum of light. It can measure the intensity of light by diffracting light into its spectrum at different wavelengths and receiving it with a detector. Normal image sensors are not able to capture high-intensity and low-intensity signals simultaneously due to insufficient dynamic range. OPAL-Luxe uses Hamamatsu Photonics' innovative photodetector to detect high-intensity and low-intensity signals in one step. The upper area collects bright signals, and the lower area collects weak signals. By setting a short exposure time for the upper area and a long exposure time for the lower area, simultaneous measurement of bright strong signals and weak signals, which are normally difficult to detect, is now possible. However, since bright light also enters the dark area in the lower half of the spectrum, the measurement is made with measures to prevent the bright signal from overflowing into the surrounding area when saturated with strong light. This is an actual measurement of dark signal. The noise level is the same as a conventional spectrometer. The laser was turned on and a laser spectrum of 632.8 nanometers was detected. Even very strong signals are detected without saturation. Furthermore, as we zoom into the graph, it is clear that while OPAL-Luxe detects this strong signal, it also clearly detects the weak emission of impurity gases at a high SN. Conventional spectrometers cannot detect these signals because they end up buried in noise. OPAL-Luxe is capable of high dynamic range measurement and can measure such strong and weak spectra simultaneously. The incorporation into a component analyzer utilizing light absorption enables the simultaneous analysis with high accuracy of components that are abundant in the sample and absorb large amounts of light, as well as trace components that absorb small amounts of light. As a result, the efficiency of component analysis can be improved in quality control of chemicals and pharmaceuticals because impurities contained in trace amounts can be detected without having to perform multiple measurements. In addition, highly accurate analysis of plasma emission, in which strong and weak signals exist simultaneously, is expected to advance applied research on plasma. OPAL-Luxe achieves high SN measurement performance, even in low light conditions, making it suitable for plasma luminescence measurements where strong and weak luminescence exist simultaneously. The ultra-high dynamic range performance also enables high optical density measurements. This graph shows the results of measuring the OD values of holographic filters for OPAL-Luxe and our conventional models. With its superior wavelength resolution and stray light characteristics, the OPAL-Luxe is also expected to improve the accuracy of film thickness measurement compared to conventional products. We will present solutions for semiconductor manufacturing equipment manufacturers, mainly on an OEM basis, in combination with LDLS. These will be suitable for their manufacturing equipment and will be demonstrated with the new film thickness gauge. This is an example of photoluminescence measurement of the compound semiconductor gallium nitride excited by a helium-cadmium laser. Band edge emission and fluorescence spectra that could not be detected by our conventional models were able to be measured with a high shorter to SN ratio. The OPAL-Luxe is our flagship multi-channel spectrometer that maximizes its high dynamic range and combines high sensitivity, high wavelength resolution, and low stray light characteristics.